So the first question is relative to the origin, the position vector of the points A, B, and C are given by OA, OB, OC. Show that OABC is a rectangle. So if OABC is a rectangle, then OA and BC should have the same magnitude, and OA and AB should intersect at right angles. So for a rectangle to be a rectangle, two conditions must be fulfilled. One, it should intersect, the side should intersect at right angles. Number two, the opposite side should be equal to each other. So let's try and find out whether two conditions are being fulfilled or not. So OA is 5 minus 2 and 1. So if OA is 5 minus 2, 1, then its magnitude is under root of 5 square plus minus 2 square plus 1 square. That is 25 plus 4 plus 1. That is under root of 30. Now let's find out what the magnitude of BC is. To find out the magnitude of BC, I first need to calculate BC, that is BO plus OC. So BO is minus 8 minus 2, 6, and OC is 3, 4, and minus 7, which makes BC as minus 5, 2, and minus 1. Minus 5, 2, and minus 1. And once again, if I check its magnitude, it will be under root of 30, which is obvious, right? Now, let's check the magnitude of OC. OC is 3, 4, minus 7. 3 square plus 4 square plus minus 7 square. 9 plus 16 plus 49. Under root of 74. So if this is under root of 74, this is also under root of 74. But let's first prove whether it is under root of 74 or not. So for that, we will need to find out AB. AB is AO plus OB. AO is minus 5, 2, minus 1, plus OB, that is 8, 2, and 6, which is once again 3, 4, and OB is AO is minus 5, 2, and minus 1. OB is 8, 2, and minus 6. So this is minus 7. Now please note these two are same. Hence their magnitudes are same. Hence this is also under root of 74. So the first thing has been proved, that the two sides, the opposite sides of both the opposite sides of rectangle are equal in length. Agreed. एक कंडीशन प्रूव हो गई, बट इससे तो हो सकता है पैरेललोग्राम होता, इससे ये बात तो प्रूव नहीं हो रही कि ये रेक्टेंगल है, इससे तो ये प्रूव हो रहा है कि पैरेललोग्राम है. ऑपोजिट साइड्स आर पैरेलल टू ईच अदर, ऑपोजिट साइड्स आर इक्वल इन लेंथ. अग्री. To prove that it's a rectangle, we also need to identify that all the sides intersect at right angles. So कोई भी एक opposite side, कोई भी एक adjacent side को prove कर दोगे वो right angle पे intersect कर रही है. So AOC has to be 90 degrees. So we need to check OA dot OC is 90 degrees, which means OA dot OC should be 0. I hope everyone agrees with this. So OA is 5 minus 2 and 1. OC is 3, 4, and minus 7. 5 into 3 is 15. Minus 2 into 4 is minus 8. 1 into minus 7 is minus 7, which is 0. Hence, proved as rectangle. Yeah, hence proved that OABC is a rectangle. I hope this is clear and I hope this makes sense to all of you. The next part of the question is use a scalar product to find acute angle between the diagonals OABC. So angle between the diagonals OABC uh, will be simply if I find the directional vector of AC, directional vector of OB, and I find its angle. So directional vector of AC is AO plus OC. AO is -5. 2 and -1. OC is 3, 4, and -7. -2, 6, and -8. So this is AC. OB is already given, that is 8, 2, and -6. And I will find the angle between these two. So cos theta is -2, 6, -8. 8, 2, -6. Under root of 4 plus 36 plus 64. 64 plus 4 plus 36. -16 plus 12 plus 48 upon under root of 104, under root of 104, cos inverse. So this turns out to be -16 plus 12 plus 48, 44 upon 104. Cos inverse is 64.97 degrees, which is approximately 65 degrees. Is this clear, everyone? I hope this makes sense. I hope this is clear. I hope you all have understood. The next question is the points A, B, and C have position vectors this, where O is the origin. Line L1 passes through B and C. So find the vector equation of L1. R is equals to A plus lambda B, 5, 2, 0, plus lambda times of 8 minus 5, 5 minus 2, -3 minus 0. So R is equals to 5, 2, 0, plus lambda times of 3, 3, minus 3. Agreed? If on the other hand, someone decides that he or she will use this point instead, 8, 5, minus 3, plus lambda times of, obviously the directional vector will remain same, then this is also acceptable. Both are correct. Are you all with me? The line L2 has this vector equation. अच्छा, it is also advisable अगर सवाल IJ की फॉर्म में है तो जवाब IJK की फॉर्म में दिया जाए, सवाल कॉलम वेक्टर फॉर्म में है तो जवाब कॉलम वेक्टर फॉर्म में दिया जाए. सो अगर मैं इसको IJK की फॉर्म में देता हूं तो दिस विल बी R इज इक्वल्स टू 5I प्लस 2J प्लस लैम्डा टाइम्स ऑफ 3I प्लस 3J minus 3K. Similarly, if this would have been given in IJ form, in Cartesian form, then this would have been 8I plus 5J minus 3K plus lambda times of 3i plus 3j minus 3k. I hope this is clear, everyone. Then the question says L2 has this equation. Find the coordinates of the points of intersection of L1 and L2. So आप वर्किंग किसी भी फॉर्म में कर सकते हैं. फाइनल आंसर्स जिस फॉर्म में क्वेश्चन है उस फॉर्म में देना एडवाइजेबल है. सो सवाल इज इन कार्टेशियन फॉर्म, यू कैन वर्क इन कॉलम वेक्टर फॉर्म, कोऑर्डिनेट फॉर्म. द क्वेश्चन इज इन कॉलम वेक्टर फॉर्म, you can do the workings in Cartesian form, that is IJ form. So that is your call, your choice. But please make sure you give the answer in the form of the question. So for convenience, R1 is 520 plus lambda times of 3 minus 3, which is equals to R2, that is 214 plus mu times of 1 minus 2, because they both are intersecting. I will equate them. This will become 5 plus 3 lambda, 2 plus 3 lambda minus 3 lambda, and this will be 2 plus 3 mu, 1 plus mu, 4 minus 2 mu. Minus minus 2, 1 and 4. Minus 2, 1 and 4. I hope this makes sense. So the first thing that we need to do is we need to identify whether they are intersecting or not. And the next task is to find the value of lambda and mu. And then third task is to find the point of intersection. So the very first thing is, but since the question has already identified that they are intersecting, there is no need to prove it, but we just need to at least find the value of lambda and mu. So 5 plus 3 lambda is minus 2 plus 3 mu. 3 lambda is minus 2 minus 5 plus 3 mu. 3 lambda is minus 7 plus 3 mu. Lambda is minus 7 plus 3 mu upon 3. Two plus 3 lambda is 1 plus mu. 3 lambda is 1 plus mu minus 2. Lambda is mu minus 1 upon 3. In both the equations, I have found lambda as the subject. I have made lambda as subject of the formula. Minus 7 plus 3 mu upon 3 and mu minus 1 upon 3. Minus 7 plus 1, mu minus 3 mu. Minus 6 is minus 2 mu. Mu is 3. Once mu is 3, lambda is mu, that is 3 minus 1 upon 3, which is 2 upon 3. Now let's check by putting it into the third equation. Minus 3 lambda, that is 2 upon 3, and 4 minus 2 lambda is 3 minus 1 upon 3. It's 2 upon 3. I have substituted lambda in this. Lambda is mu, that is 3. Mu, that is 3 minus 1 upon 3. If I substitute lambda in this, lambda is minus 7 plus 3, mu is 3 upon 3 is 2 upon 3. आप चाहे इसमें डालें या उसमें डालें, सेम आना चाहिए. एंड दोनों में 2 अपॉन 3 आ रहा है. लैम्डा इज 2 अपॉन 3 माइनस 3 लैम्डा इज 2 अपॉन 3. 4 माइनस 2 म्यू दैट इज 3. ये माइनस 2 है, ये भी माइनस 2 है. राइट हैंड साइड इज लेफ्ट हैंड साइड, which is very clear indication that the lines are intersecting and we are doing things in an absolute correct manner. Then the question says we need to find the point of intersection. Once lambda और mu आ जाए तो उसके बाद पॉइंट ऑफ इंटरसेक्शन के लिए दोनों में से किसी भी एक इक्वेशन में डाल दें. ठीक है, दैट इज आर कॉल. सिंस आई एम रनिंग शॉर्ट ऑफ स्पेस, मैं जरा यहां पे लिख रहा हूं आर इज इक्वल्स टू 5 2 0 प्लस लैम्डा विच वॉज 2 अपॉन 3 3 3 minus 3, which is same as 5 plus 2 2 plus 2 and 0 minus 2. So the point of intersection turns out to be 7 4 and minus 2. I hope this makes sense and I hope this is clear. दूसरी में भी डालते तो सेम ही आंसर आता. The question then says that point D on L2 is such that AB is equals to BD. The point D, let's say this is point D on L2. L2 is minus 214 plus mu times 3 1 minus 2. AB is BD. So the point D will turn out to be minus 2 plus 3 lambda, 1 plus 3 mu, 1 plus mu, and 4 minus 2 mu. Are you all with me? AD, AB is equal to BD. We have already found AB. No, we haven't. So we'll find AB. AB is AO plus OB. AO is minus 214. OA is minus 214. So AO will be 2 minus 1 minus 4. 2 minus 1 minus 4. And OB is 520. So AB is 7 1 minus 4. The question says AB is equal to BD. It means that the magnitude of AB is equal to magnitude of BD. So for BD, it will be BO plus OD. BO is minus 5 minus 20. OD is minus 2 plus 3 mu, 1 plus mu, 4 minus 2 mu. Minus 5 minus 2 is minus 7 plus 3 mu. Minus 2 plus 1 is minus 1 plus mu. 4 minus 2 mu. So AB and BD की लेंथ सेम है, तो 7 स्क्वायर 1 स्क्वायर minus 4 square minus 7 plus 3 mu square minus 1 plus mu square and 4 minus 2 mu square. Square root will cancel off from both sides. 7 square is 49 plus 1 plus 16. I will expand each of these values. 49 plus 49 minus 42 mu. 49 minus 42 mu plus 9 mu square. I hope everyone is following me. 1 minus 2 mu plus mu square, 16 minus 16 mu plus 4 mu square. All good, all clear? 9 mu square, 10 mu square, 14 mu square. 66 is 14 mu square minus 42 mu minus 2 mu minus 44 mu minus 16 mu minus 60 mu 49, 50 and 16. That is also 66. I hope this makes sense. 66 cancels off with 66. 14 mu square is 60 mu. Mu cancels off, mu is 0 and mu is 60 upon 14. Mu is 60 divided by 14, that is 30 upon 7. Once mu आ गया, I will substitute mu in the value of d and I will find the value of d. So this is d is minus 2 plus 3. Mu is 30 upon 7. 1 plus 30 upon 7 and 4 minus 2 into 30 upon 7. So the answer will turn out to be, please do the calculations, minus 2 plus 90 upon 7, 76 upon 7, 1 plus 30 upon 7, 37 upon 7, and 4 minus 60 upon 7. Minus 32 upon 7. Am I clear? Is this clear, everyone? अच्छा प्लीज नोट करें, आपको बोला है द पॉइंट डी लाइज ऑन L2 सच दैट ए बी इज इक्वल टू बी डी. क्या ए बी और बी डी के ऊपर एरोज हैं जो वेक्टर के निशान होते हैं? जब वेक्टर के निशान ऊपर ए बी और बी डी के ऊपर नहीं है, इट्स एन इंडिकेशन कि ये मैग्नीट्यूड्स की बात हो रही है. तो ए बी एंड बी डी के मैग्नीट्यूड्स सेम होंगे. वो फिर मैग्नीट्यूड के साथ एरो बनाएगा तो मैग्नीट्यूड, और खाली ए बी और खाली बी डी लिखा है, इसका मतलब है लेंथ ऑफ ए बी एंड लेंथ ऑफ ए डी. It means length of AB and length of AD are equal. Am I clear? The next question says that the equation of two straight lines L1 and L2 are this and this, where A is a constant and L1 and L2 are perpendicular. If L1 and L2 are perpendicular, the dot product of their directional vectors will be 0. 2 minus 1A dot 3 minus 2 minus 2 is 0. 6 plus 2 minus 2A is 0. Minus 2A is minus 8. A is equals to 4. Then the question says that L1 and L2 also intersect. Find the position vector of the point of intersection. So 1 minus 2, 3 plus lambda times of 2 minus 1 A की जगह पे 4 लिख देंगे. Minus 1, minus 1, minus 1 mu times of 3 minus 2 minus 2. So 1 plus 2 lambda minus 2 minus lambda 3 plus 4 lambda is equals to minus 1 plus 3 mu minus 1 minus 2 mu minus 1 minus 2 mu. So if I solve this equation first, this is 2 lambda is minus 2 plus 3 mu. Lambda is minus 2 plus 3 mu upon 2. Minus 2 minus lambda minus 1 minus 2 mu minus lambda is minus 1 plus 2 minus 2 mu minus lambda is 1 minus 2 mu. Lambda is minus 1 plus 2 mu. Now I will simultaneously solve the two lambdas. Minus 2 plus 3 mu upon 2 is minus 1 plus 2 mu. Minus 2 plus 3 mu is minus 2 plus 4 mu. Minus 2 cancels off. Mu is equal to 0. If mu is 0, lambda is minus 1 plus 2 into 0. Lambda is minus 1. So if lambda is minus 1 and mu is 0, अगर म्यू 0 डालते हैं तो ये पॉइंट ऑफ इंटरसेक्शन आता है, और जब लैम्डा माइनस 1 डालते हैं तो चेक करें क्या पॉइंट ऑफ इंटरसेक्शन सेम आ रहा है। आ रहा है तो आपने सही किया। 1 - 2 3, लैम्डा इज -1, 2 - 1 4, so 1 - 2 -2 + 1 3 - 4 is -1 -1 -1, so the point of intersection is -1 comma -1 comma -1. I hope this is clear and I hope it makes sense. We can do any of the three equations. मतलब हम इन दोनों को सॉल्व करें, या हम इन दोनों को सॉल्व करें, या हम इन दोनों को सॉल्व करें। किसी को भी सॉल्व करके solve any two which you find convenient and substitute in the third to ensure that the lines are intersecting. It does not make a difference कि order में चले, any that you find convenient. हाँ बिल्कुल, बिल्कुल ऐसा हो सकता है कि क्योंकि इस वाले केस में ये दोनों एक्सप्रेशंस बिल्कुल सेम है तो ये और इजी हो जाएगा। बिल्कुल ऐसा पॉसिबल है। Then the question says that A has a position vector 5i minus j minus 9k. Show that A lies on L1. So L1 was R is equals to 1 minus 2 and 3 plus lambda times of 2 minus 1 and 4. If you have to prove that it minus 5, 1 and minus 9 line on lies on this, convert this into a point. 1 plus 2 lambda is minus 5. Minus 2 minus lambda is 1. 3 plus 4 lambda is minus 9. And show that lambda is same in all the three. 2 lambda is minus 6, lambda is minus 3. Minus lambda is 1 plus 2, lambda is minus 3. 4 lambda is minus 9 minus 3, lambda is minus 3. Since it is proved that lambda is same in all three instances, it is an indication that the point lies on the line. I hope this is clear, everyone. The point B is the image of A after reflection in L2. So ये L2 है. L2 is R is equals to -1 1 -1 -1 -1 plus mu times 3 minus 2 minus 2, 3 minus 2 minus 2. And point A is -5, 1, -9. If L2 is the line of reflection and this is point A and B is the image after reflection, तो एक तरीका इसको करने का ये है कि मैं ये पॉइंट ऑफ इंटरसेक्शन निकाल लूं. वंस ये पॉइंट ऑफ इंटरसेक्शन आ जाएगा, इट विल एक्ट एज अ मिड पॉइंट. आर यू ऑल विद मी? एंड B कैन बी फाउंड अकॉर्डिंगली. सो प्लीज आइडेंटिफाई कीजिए कि ये पॉइंट ऑफ इंटरसेक्शन तो this point is -1 + 3 mu, -1 - 2 mu, -1 - 2 mu. इसका डायरेक्शनल वेक्टर निकालें. -1 + 3 mu, -5, -1 - 2 mu, -1, and -1 - 2 mu, +9. So this directional vector turns out to be 3 mu minus +4, -2 mu -2, -2 mu +8. इसका डॉट प्रोडक्ट इसके साथ 3 mu +4, -2 mu -2, -2 mu +8. 3 -2 -2. The dot product is 0. 9 mu +12 +4 mu +4 mu +4 +4 mu -16 is 0. So 9 mu +4 mu is 13 mu. 13 mu +4 mu is 17 mu. 17 mu is 16 -4 -12, which is once again 0. Agar mu is 0, then this point of intersection is -1 -1 -1. Agreed? So this will act as a midpoint, x, y, z. So -5 plus x divided by 2 is -1. 1 plus y divided by 2 is -1. And -9 plus z divided by 2 is -1. So x turns out to be 3, y turns out to be -3, and z turns out to be 7. So the point of reflection is 3, -3, म्यू पता होता तो हम नेगेटिव रेसिप्रोकेट कर लेते ना. हमने म्यू निकाला था वो उस सिचुएशन के लिए निकाला था जो पहले निकाला था. जो म्यू 0 निकाला था वो इस सिचुएशन के लिए निकाला था. लेकिन द हैक इज, प्लीज नोट करें, इससे पिछले वाले पार्ट में आपने प्रूफ किया है ए लाइज ऑन L1. अगर आप ऑलरेडी ये बात प्रूफ कर चुके हैं कि ए लाइज ऑन L1, इट इज अ क्लियर इंडिकेशन कि म्यू जो पिछले पार्ट में आया था वही म्यू इस पार्ट में होगा, क्योंकि हमने तो ये ऑलरेडी प्रूफ कर लिया था कि L1 एंड L2 इंटरसेक्ट. तो इसका मतलब L1 and L2 are intersecting at this particular point. So point of intersection was already known. Since point of intersection was already known, हमें ये सारी वर्किंग नहीं करने की जरूरत थी। इस पर्टिकुलर सवाल में जरूरत नहीं थी। नॉर्मली अगर पॉइंट ऑफ रिफ्लेक्शन का सवाल आता है तो ये सब करना है। इस पर्टिकुलर सवाल में सवाल ने क्योंकि साफ साफ बोला हुआ है दैट ए लाइज ऑन L1, और आपने ये बात प्रूफ करी हुई है, इसका मतलब द पॉइंट ऑफ इंटरसेक्शन बिटवीन ए L1 एंड L2 इज द फुट ऑफ परपेंडिकुलर। सो ए पता है मुझे, मुझे फुट ऑफ परपेंडिकुलर पता है, तो मैं डायरेक्टली इस सवाल को मैं डायरेक्टली सॉल्व कर सकता था। ये वाला पॉइंट और ये वाला पॉइंट वुड हैव एक्टेड एज मिड पॉइंट एंड आई वुड हैव फाउंड बी, इसलिए 2 मार्क्स है। क्योंकि इस सवाल में ऑलरेडी प्री हिंट है, इसलिए ये 2 मार्क्स है। अग्रीड। अगर ये नॉर्मल कोर्स ऑफ क्वेश्चन होता जिसमें ये वाली हिंट नहीं होती, देन इट वुड हैव बीन इजीली 4 to 5 marks, एंड देन यू हैव टू डू ऑल दिस वर्किंग। इन दिस पर्टिकुलर क्वेश्चन दिस वर्किंग वाज नॉट नीडेड, वी डिड इट, एक तो कॉन्सेप्चुअली इनहांस करने के लिए कि ये इस तरीके के सवाल ऐसे करना है, और दूसरा उस वक्त रियलाइजेशन ही नहीं हुई कि ये इशू था। जैसे रियलाइजेशन हुई, भी रियलाइज की 2 मार्क का सवाल के लिए इतनी मेहनत करने की नीड नहीं थी। ठीक है जी, चले, थैंक यू।